So i- if this is, he says there is a sound wave and the loudness of the sound wave uh, increases at the same pitch, and explain any change that would be in the pattern of the wavefront. Uh, what is a, this is a wave, this is a longitudinal wave. And if a and we also have a transverse wave. So the transverse wave is something like this. This is also in a sense transverse if you see the pressure variation. So pressure is varies like this only. Uh, if if you have a transverse wave like in on a rope, then you say uh, or you say something in loudness is increasing. Now, what is, how is loudness connected to, loudness is like the energy which it has. So the energy or the intensity, we can call it, depends on the amplitude. That's the most important. So intensity is k times is square. A constant time is amplitude square. So if it's becoming loud, if it's, huh? I so this is the intensity or the energy is k constant into amplitude square. So if something has become more loud, that means obviously the amplitude has increased. If he says at the same pitch, that means neither has the frequency changed. Same pitch means same frequency, and if the frequency doesn't change, the wavelength is same. So because the speed is dependent on both of them, and the speed is constant, the medium decides the speed and is still in the same medium. He's talking of air presently. Then he goes into water later. So right. So he says, is the loudness of has increased? Any change that would be in the pattern of the wavefront. So if I say the amplitude has increased, this is huh? No, no, hold on. The amplitude is increased is easier to understand in transverse, but how do you understand that in longitudinal? That is the issue. You see, it's like this. If the amplitude has increased and the wavelength is the same, that means the position of these is same. You see, the wavelength and frequency are same. So these positions can't change. But if the amplitude is more, that means the no the this will get compressed more. So you will have to draw these lines closer to this. Uh, the gap should increase. This gap should, like, if it's, let's say it's 1 centimeter, make it 2 centimeters now. Take them here. Then take the other gap lesser, because I mean to say these layers are now more compressed towards the frequency, saying the position of this is fixed. The pressure has increased. This is the pressure. The pressure is increased. So pressure will only increase if the density increases. So that means you bring all these layers closer to the compression now. You can't now because the frequency, that means the frequency is changing. This, that won't make any difference. That just the wavefront increases. That doesn't make a difference. You see, it's like this. You have these points here, and initially there was nothing. So they, now after that you try to compress them. This one came here, this one went here. But now you compress it more, that's all. Take it slightly away. All these points, no frequency, no, we are not changing the wavelength. This position we will keep fixed. The compression position will remain same where they were. Compression remains where it is. The rarefaction remains where it is. Only these layers, these lines, they shift more towards this. We are not adding more wavefronts. Wavefronts are just, what are wavefronts? Wavefronts are just um, compression crests. So the crests have just gone closer to the compression. You say that the state and explain any change that would be in the pattern of wavefront. You say the density at the compression increases, the density of the layers of the wavefronts, the you can say the density of particles or wavefronts near the compression increases, and the density, the pressure, you can all write all this, the pressure, density, and the dense of wavefronts, particles and wavefronts decreases, near the increases, and correspondingly, uh, the pressure, density of particles or wavefronts decreases near the rarefaction. Is the opposite happens near the because what is happening is this is going up. The pressure is going up at the compression. This is a compression. The pressure going. This is if this is pressure, the pressure at the compression is going up, and the rarefaction is going down. This is the pressure displacement graph. Oh, hold on, I'll look for better words. When you are having more loudness, that means you have more energy. If the energy is more, then the particles are vibrating more. So they are vibrating more here. So that's why the more energy pushes the particles closer together. Like these part is coming from this side, this side. So in the compression, it's becoming closer. And here they are because they are going at a fast speed, so they move away quickly from the rarefaction. So they are less dense here. So rarefaction thickness increases, compression density increases, particles are pulled further apart because of high energy, and more energy pushes closer together. And of course, when there is no change in the frequency, there's no change in the distance. And you see the particle velocity is increasing. This is the reason why this is happening. From the rarefaction, they are pushed further apart, and from the they come to the compression. That's what happens. Uh, when we this is the wave it's this is the wave is going, and this is right now going in air, it's traveling in air, then it comes across water. So we know the speed of sound in water increases. So if the speed has increased, the frequency never changes, only because frequency is decided at the birth of the wave. When the wave was given birth by some oscillation, that frequency, the wave is traveling at that frequency, so that can't change. Somebody was vibrating a string, and the frequency won't change. He was vibrating at some frequency. So speed in air, speed in water. So the water has increased, so frequency is same. So speed is equal to lambda into frequency. Speed is air is in water is lambda into frequency. If this has increased and this is constant, this has to increase. So lambda has increased. So if lambda increases, the difference between compression will increase, because this is one wavelength. So this difference between two rarefactions will increase. So it's like if you will say, state and explain the change in the pattern of wavefronts. So speed increases, lambda increases, the gap between compressions and rarefactions increases.